Hello everyone, this is Sir Marvin Bartido. So for our discussion today here in Geotechnical Engineering 1, we are going to discuss the third lesson, which is the relative density of soil. So for this topic class, we are going to determine the relative density of soils, no? And we are also going to discuss here the importance, no, of identifying the relative density of soils. Okay, let's start our discussion. Okay, so let's define first what is relative density. So the term relative density is commonly used to indicate the in situ denseness or looseness of granular soil. So denseness, yan yung pagiging compact ng soil natin. On the other hand, yung looseness class, yan yung pagiging buhaghag, okay, nung soil natin. So, class, kadalasan, sinosolve natin class yung relative density ng mga cohesionless soil. Okay, so ano ba yung mga cohesionless soil? So ito class yung gravel, yung sand, no? So yun class yung mga usual na type of soil na kinukuhanan natin ng relative density. So to solve the relative density, okay, so we can use this formula. So this is D sub R is equal to E sub max minus E over E sub max minus E sub mean. Okay, wherein yung D sub R, so that is the relative density. So yan class yung notation natin for relative density. And this is usually given as a percentage. And then yung E, that is the inside void ratio of the soil. So yun class yung void ratio niya, no, nung lupa na nasa site. Okay, tas class yung E sub max, so this is the void ratio of the soil in the loosest state. Okay, and then yung E sub mean naman, void ratio of the soil in the densest state. So class ganito, no, kapag yung soil natin is in its loosest state, okay, so class, yung void nung lupa natin, ibig sabihin class, ay mataas. 'Di ba? Kaya buhaghag yung lupa is because, yun nga, malaki class, no? Dahil buhaghag yung lupa, malaki class yung volume nung voids natin. 'Di ba? And dahil malaki yung volume ng voids natin, class, tumataas din class yung void ratio. Kasi class, take note, ang void ratio, yan ay volume ng void over volume ng soil solid. So, habang tumataas class yung volume ng void, 'di ba? Nagiging maximum siya class yung void ratio. Kaya class, yung void ratio natin is maximum in the loosest state ng soil. On the other hand class, kapag dense class yung ano natin, yung soil natin, if it is in its densest state, okay, so yung void natin dito or yung volume ng void is maliit. Tama, maliit class yung volume ng void at dahil maliit yung volume ng voids natin class, yung void ratio natin will also be minimum. 'Di ba? Kaya class, minimum yung void ratio natin kapag densest state. Nasa densest state yung lupa. Okay, so class ganito, no? So yung importance ng relative density, ma-appreciate natin yan class kapag settlement yung pinag-uusapan. Okay, so class, sa settlement kasi, 'di ba kapag yung lupa natin is in its, let's say, loosest state. So malaki yung void, no? Malaki yung void. So class, kapag pinatungan natin yung lupa na yun class ng, let's say, ng structure, no? So kumbaga merong ano, no, load class na mapapasa dun sa lupa dahil dun sa binild mo na structure doon. So class, kapag na-applyan ng load yung lupa na yun class, ano yung mangyayari? So class, ang mangyayari is magmo-move yung soil particles. 'Di ba? Magmo-move siya kasi meron siyang space, 'di ba, para makapag-move siya kasi nga may mga void ratio. Maraming voids rather. No, so dahil marami yung voids class, okay, so yan ay magmo-move. So magse-settle class yung lupa. Class, kapag nag-settle yung lupa, class, yung structure magse-settle din siya. Taba. On the other hand, class, kapag yung lupa natin is in its dense state, okay, so yung volume ng voids ay maliit. So, ibig sabihin, class, kahit applyan mo ng load, yung lupa na yun, class, okay, so class, yung movement ng soil particles natin, dahil maliit class yung voids natin, konti lang yung voids natin, magiging minimal lang class yung settlement niya. Therefore, magiging minimal lang din yung settlement ng structure. Tama, ayan. So, ganun class, no, yung importance ng relative density, kaya natin inaalam ang relative density. Okay, so the relationship for relative density can also be defined in terms of porosity. So, class, if you're going to recall, no, na-discuss natin yan, that void ratio and porosity has relationship, no? So, kung natin class, i-express natin yung E sub max, no, in terms of porosity. So that will be N sub max over 1 minus N sub max. So kung mapapansin mo class, ito din yung ito din yung formula natin doon sa napag-usapan natin last time, no? Yung E equal siya sa N over 1 minus N. So dito class, kung maximum yung void ratio class, magiging maximum din yung porosity. Kasi class, di ba sa void ratio, kapag lumalaki yung volume ng void, edi lalaki yung void ratio. No, kapag naman sa porosity, di ba ang formula natin for porosity is volume ng void over total volume. So habang lumalaki din yung volume ng void, di ba, lumalaki din class yung porosity. Kaya class, ano yan, parallel yan. Kung maximum yung void ratio, maximum din yung porosity. So on the other hand, for E minimum class, so that will be N sub mean over 1 minus N sub mean. And then, ito class, yung yung para dun sa in situ void ratio, so yung class ay N over 1 minus N. Okay, so class, from the relationship of void ratio and porosity, now we can therefore conclude that we can express the relative density in terms of porosity. So kapag in-express natin siya in terms of porosity class, ito yung kakalabasan niya. So this is equal to 1 minus N sub mean, so quantity times N sub max minus N over N sub max minus N sub mean times 1 minus N. So class, ito, na-derive na ito, no? Pero ito class, galing lang din ito doon sa kapag pinalitan natin class yung E sub max, yung E sub mean doon sa original formula natin ng mga in terms of porosity class, no? Kapag sinimplify natin yun class, eto din class yung kakalabasan. So you can try that, no? You can try to derive this. So makikita mo class na eto class yung formula natin for relative density in terms of porosity. Ayan. So we're in class dito, yung porosity natin, yung N sub max, yan class yung porosity of the soil in the loosest state. So katulad din sa sa Emax. So, ganun din class yung N-mean. So, yung porosity natin dito class is in the densest state. Okay. So, by using the definition of dry unit weight also class, no, we can express relative density in terms of the maximum and minimum possible dry unit weights. So, recall mo class, di ba yung dry unit weight natin, no, yung formula natin para doon, yung na-derive natin na formula is GS or G sub S times gamma water over 1 plus E. Diba? Yun yung derive natin. So, if you are going to solve for E, no, kapag minanipulate natin siya and yung E yung gusto nating masolve, so ito class yung kakalabasan. So, E is equal to G sub S times gamma water over gamma dry minus 1. So, ito ngayon yung E natin, yung void ratio natin, in terms of ano na to class, in terms of gamma dry, no? So, class, kapag naman E sub max na yung kinukuha natin, so what happens is that, class, yung gamma dry natin dito should be minimum. Okay? Doon naman, class, sa gamma or E sub mean, okay, yung gamma dry dapat natin dito, class, is in maximum. Okay, so class, explain natin to, no? Kung bakit kapag E max yung hinahanap, yung gamma dry dapat niya nakasama is minimum. At saka kapag minimum yung void ratio, dapat yung kasama niya is gamma dry max. So, class, ganito. Di ba class, yung original formula natin for gamma dry, yun class ay weight ng soil solid over total volume. And yung total volume natin, it includes yung volume ng soil solid at saka yung volume ng voids. Tama? So, ganito class. Di ba class, kapag lumalaki yung void ratio natin, kapag E sub max yan, lumalaki yung volume ng voids natin. So, class, kapag malaki yung volume ng voids natin, class, di ba, lalaki yung total volume ng gamma dry. Tama? Lalaki yung total volume, class. At kapag lumalaki yung total volume sa gamma dry class, di ba, nasa denominator yung total volume. So, habang lumalaki yung class, lumiliit yung value ng gamma dry. Tama ba? Kasi nasa denominator siya eh. Diba? So, on the other hand, class, kapag minimum yung void ratio natin, okay, so ibig sabihin, maliit din yung volume ng voids natin. At kapag maliit, class, yung volume ng voids natin, yung total volume natin sa gamma dry, yan, class, ay lumiliit din. Class, habang lumiliit yung total volume, take note, nasa denominator yan. Habang lumiliit yung denominator, class, lalaki, class, yung value ng gamma dry. Kaya, class, nagiging gamma dry max siya. Okay? Nagets mo yun? So, yun yung dahilan class ha kung bakit ang magka-partner is yung E sub max tapos gamma dry min. Tapos yung magka-partner is yung E minimum tapos yung gamma dry max. Okay? Okay. Okay, so since there's a relationship no, between void ratio and the dry unit weight, we can therefore express the relative density in terms of dry unit weight. No? So from here class, no, palitan natin yung E sub max minus E over E sub max minus E sub min nung mga equivalent ano niya class, equivalent equations niya in terms of gamma dry. Okay, so ito class yung E sub max. Okay, ito class yung E. Ito yung E sub max ulit. And then ito yung E sub min. No? So from here class, kapag isinimplify natin ito, so itong mga 1 na to, makakancel lang yan. Kasi negative 1, ito magiging positive kasi negative times negative. So makakancel lang yung dalawang 1 na yan. Same dito sa baba, makakancel tong negative 1 tas ito. Kasi negative times negative magiging positive, no? And then, after nun makancel class, we can factor out yung GS, gamma water, from here at saka here. Since parehong present yung G sub S tsaka gamma water sa kanila. So, pwede natin silang i-factor out. Ganon din dito class sa baba. Diba, pwede nating i-factor out yung G sub S tsaka gamma water. Since they both have those terms, no? So, kapag na-factor out natin yung G sub S, gamma water dito sa baba, tsaka sa taas, so pwede natin silang makancel. Tama? And yung matitira na lang dito, class, is 1 over gamma dry minimum minus 1 over gamma dry over 1 over gamma dry minimum minus 1 over gamma dry max. Okay, so from here, kapag sinimplify pa natin ito, class, so ito yung kakalabasan. Okay, so yung relative density natin, class, equal yan sa gamma dry minus gamma dry minimum over gamma dry max minus gamma dry minimum, dry max over gamma dry. So, eto class, no, pwede natin ito gamitin. Okay, if yung given natin sa problem class is gamma dry minimum, at saka gamma dry max. Okay, so, from here, class, pwede rin natin class i-express yung relative density in terms of density. Tama? So, class yung yung unit weight at saka density, we already talked about their relationship. Tama ba? So, class pwede nating i-replace lang yung mga gamma, lahat ng unit weight na to. No, we can replace them no by density. So, pwede natin yung gamma dry, gagawin nating density dry minus ito gagawin natin din yan dry density no na minimum, and then ito din so palitan mo lang lahat class ng unit weight ng density, so pwede yon, no? So alam natin na direct class yung relationship nila 'di ba, ng density at saka ng unit weight. Okay, so class here in table 3.3, okay, so this shows the qualitative description of granular soil deposits. Okay, so class, for this relative density in percentage, so class yung corresponding description niya class nung soil deposit natin class ay ito. So kapag yung relative density natin is 0 to 15, so yung lupa natin class is very loose. No, kapag 15 to 50 naman, loose class yung natin, yung soil deposit natin. Kapag 50 to 70 naman, medium. Kapag 70 to 85, dense. And then kapag 85 to 100% class yung relative density natin, very dense na yan. Okay. Okay, so let's solve sample problem number 1. For a given sandy soil, E sub max equal to 0.75, E sub min is equal to 0.45, and G sub S equal to 2.67. D sub R is equal to 85%, and W is equal to 12%. So from this given, now we have to compute the moist unit weight of the soil in kilonewton per meter cube, compute the dry unit weight of the soil in kilonewton per meter cube, and compute the unit weight of soil at 0 air voids in kilonewton per meter cube. So let's first break down all the given here. So we have E sub max. So this is the void ratio in the loosest state no ng soil natin. And then E sub min 0.45 yan. So yung E sub min class, this is the void ratio in the densest state, okay, nung soil natin. Okay, so Plus, dapat class yung E sub max, mas malaki talaga yan sa E sub min ha. 0.75 yan, tas E sub min 0.45. So, magtaka ka class, okay, kapag mas malaki yung E sub min kaysa sa E sub max. So, baka typo error yon or what, no? Okay. So, class yung specific gravity, given din yan, that is 2.67. The relative density, that is also given, that is 85%. And the water content, that is 12%. Okay. So from here, we have to solve the moist unit weight. So solving for the moist unit weight, plus we can use our formula here for moist unit weight, that is gamma dry times 1 plus water content. Although class, yung ano talaga natin, yung original formula natin for moist unit weight, that is total weight over total volume. But in this case kasi class, hindi naman binigay sa given class yung total weight saka total volume. No, so yung gamitin natin class is yung mga na-derive na natin. No? So ito class yung isa sa mga na-derive natin for moist unit weight. So this is gamma dry times 1 plus water content. So in this case, yung gamma dry, pwede natin yan i-express as G sub S times gamma water over 1 plus E. Okay, so yung G sub S, wala tayong problema dyan. That is given. Yung water content, this is also given. Yung gamma water, that is constant, no? Meron tayong value para dyan. Yung E-class, ito yung problema natin because hindi siya given, no? So, yung E-class, actually, pwede natin yan ma-solve, no? Using our formula for relative density. Since given class yung relative density natin, yung E sub max at saka yung E sub min natin, so we can therefore solve for the inside or in situ void ratio, no? So, using our formula for relative density, so this is E sub max minus E over E sub max minus E sub min. Okay, so yung E sub max natin is 0.75, yung E natin unknown, E sub max natin 0.75, E sub min natin 0.45. Yung relative density natin 85%, no? So that will be 0.85. Okay, so from here we can solve E. So solving for E, this will give us 0.495. So try computing that using your calculator. So, double check natin. Okay, so that is 0.495. Okay, so since meron na tayo class relative or void ratio, no? We can directly substitute that now, no, dun sa formula natin to solve for the moist unit weight. So, yung G sub S natin, 2.67, gamma water natin, 9.81 kilonewton per meter cube, and then 1 plus E, our E is 0.495, and then 1 plus W, our W is 0.12. Okay, so solving this, no, we can solve this using our calculator. 2.67 times 9.81 over 1 plus 0.495 times 1 plus 0.12. So that is 19.62 kilonewton per meter cube. So this is now the moist unit weight class. Okay, so you can now box that. Okay, now for letter B, we have to compute the dry unit weight, okay, of soil in kilonewton per meter cube. So actually, from here, since na-solve na natin yung gamma, which is the moist unit weight dito, pwede natin siyang i-substitute here. Okay, and we can directly solve for gamma dry, no? Pwede yon. So, pwede rin naman class na we directly use the formula for gamma dry, which is equal to G sub S times gamma water over 1 plus E. Since meron naman tayong G sub S at saka E, ito yon, na-solve na natin. So, we can directly solve for gamma dry. So, this will just be 2.67 times yung gamma water, which is 9.81 kilonewton per meter cube, and then 1 plus 0.495. So, if you input that in your calculator, that is 17.52 kilonewton per meter cube. So, dapat class, ano to ha? Less than ito kesa dun sa unit weight natin or dun sa moist unit weight natin. Kasi dito absent na yung water eh. Diba? Sa gamma dry. Now, for letter C, we have to compute the unit weight at zero air void. So, we have the formula class for unit weight at zero air void. So, this is equal to G sub S times gamma water over 1 plus W times G sub S. So, yung water content given naman, G sub S given naman, gamma water constant yan. So, we can directly substitute those values and we can directly solve the unit weight at zero air void. So, G sub S 2.67 and then 9.81 yung gamma water, and then yung denominator 1 plus yung water content 0.12, G sub S 2.67. So ito class ay 19.84 kilonewton per meter cube. Okay. So, ito na class, no, yung unit weight natin at 0 air voids. Okay. Let's proceed to sample problem number 2. The field density of the soil sample is 1,960 kg per meter cube, and the density of the soil particle is 2,700 kg per meter cube. If the E sub max equal to 0.69 and E sub min is equal to 0.44, compute the dry unit weight in kilonewton per meter cube if the water content is 11%, compute the void ratio of the soil sample, and compute the relative density of the soil sample. Okay, so for our given here class, the field density, that is the moist density class, so that is equal to 1,960 kilogram per meter cube. And then the density of the soil particle class, so that is for the soil particle alone, so that is 2,700 kilogram per meter cube, no? And then for the E sub max, so that is 0.69, and then E sub min, that is 0.44. Okay, plus from here, okay, for letter A, compute the dry unit weight in kilonewton per meter cube. So there's also a given water content here, so that is 11%. Okay, so class, to solve for the dry unit weight, we can actually use yung formula natin for dry unit weight in terms of the moist unit weight and water content, and that is gamma dry is equal to gamma over 1 plus water content, no? So the water content, no problem because it is given. And then for the moist unit weight class, the given here is moist density. But we know, class, that we can convert the moist density to moist unit weight. No, we can convert that. Kasi class, ang kailangan natin dito, dry unit weight, no? Okay. So class, converting the moist unit weight, or moist density rather, to moist unit weight, that is gamma is equal to rho times g, wherein yung g dito, class, this is the acceleration due to gravity, and this is in SI unit, no, since kilogram per meter cube. So we will multiply it by g, which is 9.81 meter per second squared. Okay, so class, the result here will be 19,227.6. So kilogram times meter per second squared, that is Newton, class, ha. Okay, so over meter cube. So we can convert this into kilonewton by dividing it in by 1,000. So that will become, this will become 19.228 kilonewton per meter cube. So this is now the moist unit weight. So we can directly use this, class, dito sa formula natin, together with the water content to solve the gamma dry. So our moist unit weight here, class, is 19.228 over 1 plus water content is 0.11. So that is, try to input this in your calculator. So this is 17.32 kilonewton per meter cube. So this is now the gamma dry, now for letter A. Now for letter B, we are going to compute here the void ratio of the soil sample. So class, void ratio, we can yung formula natin kasi dito ay volume ng void over total volume, which is hindi sila given dito sa problem. Pwede rin natin gamitin yung sa relative density kasi may Emax Emin tayo. Kaya lang, wala naman tayong given na relative density. No, so, hindi rin natin yun pwedeng gamitin. So, class, ang gawin natin, di ba may gamma dry na tayo? Di ba sa gamma dry, yung formula natin doon, G sub S times gamma water over 1 plus E. Yung gamma water, wala tayong problema doon kasi constant yon. Yung G sub S, class, problema, hindi rin siya given sa problem. Pero class, you will notice, class, dito sa problem natin, may binigay dito, class, na density ng soil particle. No, di ba, class, yung density at saka specific gravity, no, actually, meron din sila, class, relationship, eh. Di ba? We know, class, na yung specific gravity equal siya, class, doon sa density ng anumang material over density of water. Same lang din yon na unit weight ng material over unit weight ng water. Diba? Specific gravity din yon. So, pwede natin gamitin ito class. 'Di ba? Ito class yung density nung soil solid over the density of water, which is alam natin class yung density ng water. So, pwede natin yun gamitin class. No, pwede natin ito gamitin. No, since makukuha natin yung G sub S. So, yung E na lang class yung magiging unknown natin. So, isolve natin class yung specific gravity. So, yung specific gravity, this is the density class nung soil solid natin over density ng water. Okay, so yung density ng soil solid, 2,700 kg per meter cube. And then yung density class ng water, di ba constant na yun? Na yun class ay 1,000 kg per meter cube. Okay, so 2,700 divided by 1,000. So class, yung specific gravity ng soil solid natin ay 2.70. So yun yung gagamitin natin. Okay, so yung gamma dry natin is 17.32. G sub S, 2.70. Gamma water, 9.81 kilonewton per meter cube. And then yung E natin, class, yan yung hinahanap na. Okay, so solving for E here. Okay, solve natin. So you can input that in your calculator. Okay, so class, yung lalabas class sa calculator ay, so this is 0.529, no, for the void ratio. So class, this is already the answer for letter B. Now, for letter C, compute the relative density of the soil sample. So, class, we can directly use, no, our formula for relative density in terms of Emax, E at saka E-min. So, since meron naman tayong Emax, we also have E-min, and we already computed the value of the in situ void ratio, which is ito. Okay, so substitute lang natin lahat ng values natin, class. So, yung E sub max natin, 0.69. Yung E natin, 0.529. Emax ulit, tas E-min natin 0.44. So, solving class, the relative density. So, this is input in our calculator class. So, this is 0.644, no? Or if we're going to make it in percent, no? So, this will be 64.4%. So, this is now the relative density of the soil sample. Now, for sample problem number 3, a loose, uncompacted sand field, 1.8 meter in depth, has a relative density of 40%. Laboratory tests indicated that the minimum and maximum void ratios of the sand are 0.46 and 0.90 respectively. The specific gravity of the soil solids of the sand is 2.65. So, determine the void ratio of the sand. What is the dry unit weight of the sand? And if the sand is compacted to a relative density of 75%, what is the decrease in the thickness of the 1.8 meter field? Okay, so from here, class, our given, no, so we have E sub max, which is 0.90, and E sub min, which is 0.46. We also have specific gravity of the soil solid, which is 2.65. So, plus relative density is also given, that is 40%. Okay, so to solve for letter A, so we are going to solve here the void ratio of the sand. Okay, so obviously we can directly solve the void ratio of the sand by using the relative density and Emax and E-min. Okay, so our Emax class is 0.90, E-min 0.46. And then, relative density is 40%, so this will be 0.40 here. So, the only unknown here is E. So, solving for E, so we can compute this using our calculator. Okay, so, class, the answer for this is 0.724. So, this is the void ratio class, no, of the sand. So, this is for letter A. Now, for letter B, what is the dry unit weight of the sand? No? For the dry unit weight class of the sand, we can use our formula for gamma dry, that is G sub S times gamma water over 1 plus E, wherein yung G sub S that is given, gamma water that is constant, E is already computed. So we can directly solve for gamma dry. So solving for gamma dry class, we just substitute all the values here. So 2.65 for G sub S, gamma water is 9.81 kilonewton per meter cube. And then yung E, that is 0.724. So that is 15.08 kilonewton per meter cube. So this is now the gamma dry. Now, for letter C, the question here, class, if the sand is compacted to a relative density of 75%. So, originally, class, yung relative density nung soil natin is 40%. So, dito, class, ang gustong gawin is i-compact pa siya, no, yung soil natin, no, hanggang yung maging relative density niya ay 75%. So, the question here, class, is what will be the decrease in the thickness? No, or this will be the change of the thickness, no. So originally, class, yung thickness nung fill natin is 1.8 meter. So this is the thickness of the fill kapag 40% yung relative density natin. So class, kapag na-increase yung relative density, so of course mako-compact yan, 'di ba? Mas magiging compact siya. So yung mangyayari, class, magdi-decrease talaga yung ano natin, yung thickness natin, 'di ba? Nung ano natin, nung soil fill natin. Okay, so class, yung gagawin natin dito, no, kailangan muna natin, class, no, so ito, class, yung ano, no, yung gagamitin nating formula to solve the decrease, no, or the change in the thickness. So this will be equal to the original thickness, which is 1.8 meter fill. So this is the thickness at 40% relative density. And then let's say yung T prime, class. So this is the thickness, class, no, kapag kinompak natin ng 75%, no, yung ito yung naging relative density, no. Okay. So, from here, class, we have to solve T prime. So, para ma-solve natin, class, yung T prime, no, alamin muna natin, class, yung magiging pagbabago doon sa void ratio. So, let's solve the change in the ratio, no, yung magiging bagong ano natin, void ratio, no, because of the new relative density natin. Okay, so, class, yung new relative density natin is 75%, 0.75. Tapos, yung Emax Emin natin, so yan pa din yung mga yun. So, isosolve natin dito, class, yung E prime. Okay, so yung E prime, class, it will be 0.57. So, bumaba, no, bumaba yung E natin. Kasi ano na to, kumbaga, dahil tumaas yung relative density natin, 'di ba? So, yung void ratio natin, class, ay bababa. 'Di ba? Bababa kasi ano na kumbaga liliit na rin yung ano dito, volume ng voids dito 'Di ba? Kasi nga lumaki yung relative density natin. So from here, class, dahil nabago, class, yung void ratio natin, the gamma dry, it will also change. Right? So gamma dry, it will also change. So isolve natin, class, yung magiging panibagong gamma dry. So let's say ito ay gamma dry prime. So this is G sub S times gamma water over 1 plus 0. Ito mababago to, no? Kanina 0.724 ito dito. So mababago yan, magiging 0.57. Okay, so class, solving for the new gamma dry, this is 16.56 kilonewton per meter cube. So this is the gamma dry, class, at 75% compaction. So kung makikita mo, class, yung gamma dry natin tumaas. No, so habang tumataas, class, yung relative density, class, tumataas din yung unit weight, class, ng ano ha, nung ano natin, nung soil natin. So yung gamma dry ay tumaas. Okay, lumaki, no, in comparison dito sa gamma dry kapag 40% lang yung relative density. Ayan. So class, from here, no, yung class, pwede natin i-relate yung ratio nung relative nitong gamma dry na panibago, no, doon sa initial na gamma dry. Pwede natin i-relate yung ratio nila, class, doon sa corresponding volume nila. Ayan, di ba, class, yung ratio ng gamma dry na bago over yung initial na gamma dry. Class, pwede nating sabihin na yan, class, ay yung para dito sa may bagong gamma dry natin, plus yung relationship niya with the volume, no, is 1 over V prime. Okay, kasi, class, di ba yung unit weight equal siya sa weight over volume. So, ibig sabihin, class, yung relationship ng gamma dry at saka ng volume, class, ano sila, no, reciprocal yung ano nila, hindi sila directly proportional. Okay, so reciprocal, class, yung proportionality nila. Okay, so ganito yung ano niya, no, yung corresponding volume niya, class, 1 over V prime. Tapos yung corresponding volume naman for gamma dry, okay, so this is 1 over V. Okay. So, class, from here, kapag sinimplify natin to, so, class, ang mangyayari, yung V natin na to, mapupunta siya sa ibabaw. Okay. And then, yung V prime natin, which is ito yung corresponding volume, half for this gamma dry na bago. No? So, eto na class yung magiging relationship natin. And take note class na kapag volume yung pinag-uusapan, syempre habang lumalaki yung volume, no, yung thickness, lumalaki din. On the other hand, kapag lumiliit yung volume, yung thickness lumiliit. So, ibig sabihin, pwede rin nating i-relate class yung gamma dry prime at saka yung gamma dry dun sa thickness. So, yung corresponding thickness class dito sa V na to is T. And then, yung corresponding thickness para dito sa V prime is T prime. So, class itong T prime, ito yung corresponding thickness para dun sa panibagong gamma dry. No? Tapos ito namang thickness na to, ito yung corresponding thickness para dito sa initial na gamma dry. Okay, so from here class, substitute lang natin yung values nung gamma dry prime natin, which is 16.56. Ayan, tapos yung gamma dry na initial natin, 15.08. So, class itong 16.56, this is the gamma dry na yung with the relative density na 75%. And then yung 15.08, ito class yung gamma dry natin, okay, with the corresponding relative density na 40%. Now, yung initial thickness natin, class, ay 1.8, diba? 1.8. So, this is 1.8. And then, yung T prime yung hinahanap natin. So, solving for T prime, okay, so solving for T prime class, so this is 1.639 meter. So, class, mapapansin mo dito na itong T prime, mas lumiit. Diba? Lumiit ito. Lumiit ito, diba? Yung initial kasi natin, 1.8 eh. So, nagkaroon class ng decrease doon sa thickness. Kasi nga class, kinompact natin yung soil. So, this is the corresponding thickness class kapag yung soil natin, kinompact natin ng 75%. Okay, so from here class, we can now solve the decrease. No, yun yung tanong class sa problem, yung decrease in the thickness or the change in the thickness. So, substitute lang natin. So, yung original thickness natin is 1.8. And then, upon compaction, the new thickness becomes 1.639. No? So, plus the change in thickness will be 0.161 meter. Or kapag kinonvert natin yan ng millimeter, so this is 161 millimeter. So, this is now the answer for letter C. Thank you for listening. Please subscribe to the channel and like and share this video. So, see you again sa next video natin. Aral mabuti class. Bye-bye.